Right, grade 12's on to topic 2, and that's angles of inclination. So this was the big topic that we learned in grade 11. Now I'm actually going to do 2 examples in this one, but I would actually advise you to hit pause to actually do the examples yourself and then come back, because it is something that we have done before. So just a reminder of what inclination means. Basically, an angle of inclination is the angle that forms with the x-axis anti-clockwise until you hit the straight line. So that's an angle of inclination. If you have a negative gradient for a straight line, it means it's an obtuse angle, but anti-clockwise from the x-axis towards your line, that's your angle of inclination. So I've just written myself that in as a note. Now, really importantly, it doesn't have to be only from the x-axis. And so I often, and we're going to do this in one of the examples, it's also exactly the same thing as from any horizontal line. So it doesn't have to be the x-axis, it's from any horizontal line. So what this means is I often draw myself in what I call a phantom x-axis. So just think about it. Due to corresponding angles on parallel lines, this would also be theta. So I often draw myself in what I call a phantom x-axis, as I said, simply because it helps me to work in a different place, not only on the x-axis. So we'll see that in example 2. Okay, let's go down to example 1. Again, as I said, I would hit pause, try this out, and then mark. So now that you've tried it, basically if I'm trying to find the angle of alpha, don't forget that these pictures are given to you in your diagram booklet in your exam. And so you can always add in angles and label them if you want. So if they haven't labeled in theta, which they probably won't, you can label in theta. And you can label in beta. And then you can use theta and beta. You don't even have to introduce them as long as they're on the picture. Now my plan here, I always label in all my angles of inclination because then I know I can find them. So I know I can find beta. I know I can find theta. And then I think I'm going to do exterior angle of a triangle. I think that's probably the quickest way. I could do angles on a straight line and find that angle there, and then some angles in a triangle, but I find that it's probably easier to do exterior angle. So in order to find beta, don't forget that when you're finding multiple gradients, try and use subscripts to show your examiner what you're doing. So it's change in y over change in x, and that gives me a gradient of -1. Therefore, I know that tan of beta is equal to -1, and if you do shift tan, on your calculator, you get -45 degrees. Now, that can't be the angle of beta, and so don't forget that you add 180, so you get 135 degrees. So just remind yourself, if you get a negative angle, basically what it's finding is it's finding that angle there. And so I add 180 degrees to get the angle I want. Right, soldering on, I need the gradient of AC in order to continue, so that's 3 minus -2 over 2 minus -5. So that gives me 5 over 7 as far as I can see. And therefore, tan of theta is equal to 5 over 7. If I do shift tan of 5 over 7, I get theta is equal to 35. Now, I probably shouldn't round this off to 2 decimal places because I'm going to interact it now and I'm going to do a calculation with it. So I like to keep, I don't know, a couple. So now this is great. I know theta and beta, so therefore I know that alpha plus this 35, what is 54 degrees is going to equal to 135 degrees. Now, for example here, I didn't actually matter about my rounding because I'm not interacting this rounding with other rounding, and then, you can round off too early. So basically, if I subtract that answer from 135, I get alpha is 99.46. Now, really importantly, please don't forget to give a geometry reason. Great, so that's a quick recap of some easier angles of inclination. So let's do a slightly more tricky one. Again, hit pause and try it yourself. And now that you've done that, let us look at these 2 questions. So basically it says that these 2 lines are parallel. Don't forget to read the question. We often don't label things in a diagram. OT, which is the origin, O's origin, OT has an equation of 3y minus 4x equals 0, and k is given. Write down the gradient passing through k and v. Well, it's parallel to OT. Now, OT's equation is not in standard form, so if I write it in standard form, I get y is equal to 4 over 3x, which is a positive gradient, so that does make sense, but that means that the gradient of kv is also equal to 4 over 3 because the lines are parallel. Now you don't actually have to give a reason for that. Great, so that was that one done. Next one, if the distance from K to the origin is 2.5 units, find the value of m. So this is a standard working backwards question. So my distance is 2.5. So 2 over 5 is my distance, and that's equal to the square root of, and it'll be negative 2 minus 0 squared plus m minus 0 squared. Now I would prefer to square both sides immediately because I don't like square roots. So 6,25, negative 2 squared is 4, and plus m squared. Now I would subtract the 4 on both sides, and I wouldn't solve this like a quadratic equation because it's an easy question. I can just square root. The only thing for me to remember is, am I going to positive square root or negative square root? Because technically, if I square root 2.25, there's two different answers. So I get plus or minus 1.5. But if you notice where m is a y value, and that y value is positive. So, but m is greater than 0. Therefore, m is 1.5. Now, if you just went straight to m is 1.5, I would assume that you thought about all of that. Right, and our last question that I hope you've tried is find the value of theta. Now, there's many different options. So I'm going to just show you what I would have done. So personally, what I would do is I would draw what I call a phantom x-axis where theta is. If theta isn't related in any way in a triangle, so there's no exterior angle of a triangle here, there are no triangles. The moment theta is not on the x-axis, I draw in what I call a phantom x-axis, because then I can label the angles of inclination that occur here. So for example, that there is the angle of inclination of KV. Now I know that this has a gradient of 4 over 3, so finding alpha is really easy. Next thing what I would do is I would extend any line at that point. I would extend, simply because then I know that that's the angle of inclination, which I'm going to call beta, and that's the angle of inclination of KO. Now I don't know the gradient of KO, but I can work it out. So I can work out beta. Now how does that help me? Theta is not really related to kind of beta. I mean, it's not angles on a straight line with beta, but it is related to alpha and beta together. So my plan of action is, if I know beta, I can work out this angle here, simply because that would form the straight line with beta. So once I know beta, I can figure out my yellow dot. Now I'd probably need to give that a name because I'm going to work with it. So let's call it T for lack of anything else. You can call it anything, but I've run out of Greek symbols. And then alpha is this part here. So I think that theta is going to be equal to T plus alpha. So alpha is easy to figure out. T will take a little bit of steps, and then I can just add them together because theta is the whole angle. Now I find it much easier to work with this where theta is. I don't want to work on the x-axis, and hence this use of what I call the phantom x-axis. Okay, so in order to continue, I need the gradient of KO. So the gradient of KO is changing y over change in x. Fortunately, it's with the origin, so it's fairly easy. But I'm pretty sure it's 1.5 minus 0 over negative 2 minus 0. So that gives me negative 0.75. Now that means that tan of this beta angle that I labeled in my beta will equal this gradient of negative 0.75. So I can shift tan, and guess what? I'm going to get a negative angle. Now, interestingly, that negative angle is actually going to be what this T is, because that's what a negative angle is. A negative angle is clockwise from the horizontal. So now I know that that angle of T is equal to 36,87 because I can see that. However, because I'm finding B, I can't actually write that. So I'm going to add 180, and I'm not going to round off because there's going to be multiple roundings occurring here, and I'm going to get that. But that means that T is equal to 180 minus that. Now, because you've labeled T on your diagram, you don't have to introduce it. Your examiner will look at your diagram. So I get a value of T of 36,86989. I think that's enough decimal places. Now, on the other hand, I need alpha. Now, I know that tan of alpha, that gradient was given to me. Well, I kind of figured it out, as 4 over 3. So if I shift tan of 4 over 3, I get alpha is equal to 53,130,102 kind of degrees. And so finally, I know what theta is. So theta is t plus alpha. And when I add those two together, I get 89,99999, which is 90 degrees. Now, interestingly enough, the moment I saw that, I was like, hang on one moment, that's 90 degrees. Did I know that they were perpendicular? Well, actually, if I had been not just so focused on an angle of inclination, I would have noticed that this is negative 3 over 4. And the other gradient is 4 over 3. So you could have then just said, well, the gradient of KO multiplied by the gradient of KV would equal negative 3 over 4 times 4 over 3, which equals negative 1. And then you could have gone straight to the 90. I mean, that was just kind of fluke. It just happened to be 90 degrees here. I wanted to do an example, though, of where there was the phantom x-axis, because I think that's a really useful concept. Great. Now, that's the kind of wrap-up of grade 10 and 11 revision. As I've said before, we're going to do a lot of past papers. And in those past papers, these questions will come up to revise. Now we can go on to the cool grade 12 stuff. Yay.